Vulkan fence waiting behavior explained, understanding queue submissions and synchronization. Understanding fence synchronization and Vulkan queue submissions. When working with Vulkan, synchronization using fences can sometimes behave unintuitively, especially when submitting multiple command buffers to the same queue. The problem: you have code that submits two batches of work, infoB and infoA, to the same Vulkan queue using fences fenceB and fenceA. infoB takes longer, 130 ms, while infoA is quick, 1 ms. The loop waits on fenceA, resets it, then checks if fenceB has completed. Unexpectedly, after resetting fenceA, vkQueueSubmit blocks waiting on older work from outside the loop. What's happening internally? All submissions are issued to a single queue. Queue operations are serial, new work waits for all previously submitted work to complete before executing. The actual queue content after the first iteration looks like this. Your loop logic: skips waiting on fenceB initially, waits on fenceA next iteration. Since infoB is slow and submitted first, infoA's work cannot start until infoB completes. Thus, waiting on fenceA also blocks implicitly on infoB because the queue processes submissions in order. How to avoid this queue serial dependency? Use separate queues. Submitting infoA and infoB to different queues allows concurrent execution and independent fence signaling. Understand hardware limits: even multiple queues may map to the same hardware queue internally, causing serialization. Explicit synchronization: use semaphores and pipeline barriers appropriately to express dependencies. Summary: fence waits on a single Vulkan queue will inherently serialize work submissions. To achieve parallelism and avoid stalls, submissions must be distributed across multiple queues or thoughtfully synchronized. By recognizing Vulkan's queue execution model, you can anticipate fence behavior and design your synchronization strategy accordingly.